So let's talk about subcooling. That happens here in this coil. So when you hook up your refrigerant, your gauges to a system, most likely you're going to hook it up at spot number 4 here, because we're looking at an inside-outside system. So if you look at this line between number 1 right here and the dryer, we're seeing two parts of the system. We see the low section and the high section. But if you draw a line between A and C, the compressor and the metering device, everything on the right-hand side is red, which is high pressure. The metering device lowers the refrigerant, so everything on the left-hand side of the compressor and the metering device is low pressure system. The compressor rises it, the pressure, the metering device lowers the pressure. So this is a line that divides one half from the other. So if we put a gauge, which would look like this, at position 4, the liquid line, the high side, now there's going to be a high and low side both at that spot, but let's just talk about the high side as we're talking about the high side. Let's say that at that point it is at 300 psi. Your 410A came out of the compressor, went through the condensing unit, and now is setting at this spot where that metering device, that service device is right there. A little service valve where your gauge is connected, right at number 4. So it's left, the refrigerant is left here as a vapor, high pressure, high temperature, went through, changed a few degrees, and changed into a high pressure, high temperature liquid, and we're looking at it from a snapshot at that spot of number 4. So if we're looking at this gauge, let's say it's at 300 psi, which let's round it to 95 degrees. This is the pressure of the system, which is 300 psi. The purple line is 410A, and this is the temperature of 410A at this pressure. So the temperature of 410A at 300 psi is approximately 95 degrees. So when we look at position 4, the gauge will read 300 psi and 95 degrees of 410A temperature. Let's call this gauge temperature. It's not the actual temperature, it's what it should be if everything was equal. But since we have put it through a process called subcooling, it's no longer equal. If we put the gauges here at position 2, this would read 300 psi, 95 degrees, and that would be actual temperature and pressure. But after we manipulated it by taking through this coil at position 4, it's 300 psi still, but it's 85 degrees. And how we tell that, we put a thermometer right on this pipe. We tape on a little one that goes, you'll have in your kit, you have your multimeter or your amp clip that has a temperature probe on it. You tape it on to position 4 on that liquid line, leaving that coil, and it will read 85 degrees. Your gauges, which is at the exact same spot on that line, will read 95 degrees if you use the gauge. One's gauge pressure, temperature, the other's actual temperature. So gauge temperature is 95, actual temperature is 85. There's a 10-degree difference in those. That's what we call subcooling. That's something that needs to happen to make the system work. Subcooling. And again, it's the difference between gauge temperature related to the pressure of the refrigerant and the actual temperature of the pipe coming out of the condensing coil. That's 10 degrees subcooling. And without that doing that, without it changing from state from a vapor to a liquid, or a gas to a liquid, whichever word you prefer, and lowering that 10 degrees and doing that, your system will not work. It's impossible. We cannot take this coil out of this system and push this refrigeration all the way down, this one line going right to this line, going to this meter device. It might work a little bit, but it's not going to work much at all. You have to have the change of state, taking a vapor to a liquid by condensation and changing that temperature in the process about 10 degrees. Most manufacturers give you this 10 degree mark is what needs to happen to make this system work. They'll have it printed on the unit, put in instruction manuals. Some use 8 degrees, some use 12. It all depends on the equipment. It depends on the outside ambient temperature. They're all different. And your future classes will show you charts, psychometric charts, that shows you exactly what it should be. If the outside temperature is 85, the inside temperature is 75, this is what the subcooling should be. Just depends on the manufacturer's engineering of that product.